All right, let's dive right in. Today, we're going to explore a really fascinating challenge. How do we teach AI a skill that for us humans is totally second nature? The ability to actually learn from experience.
You know how it is, right? Riding a bike, typing, making your morning coffee. You don't consciously think through every tiny step every single time. And why not? Well, it's because you've got procedural memory. It's that how-to knowledge that's just automatic.
Right, but that's us. For AI, it's a whole different ballgame. For all their amazing power, most AI agents have this one really annoying problem. You could almost call it digital amnesia.
Seriously, even if an AI agent pulls off some complex multi-step task perfectly, the very next time it sees a similar problem, it just starts all over again from square one. Imagine having to relearn how to ride a bike every single morning. It's a massive waste of time and energy, and it means the AI can make the same silly mistakes again and again.
So how in the world do we fix this? Well, the key might just be to give these agents the same kind of skill memory that we have, to build a real working memory for machines.
And this gets us right back to that idea of procedural memory. Giving AI this knowing how is the key to letting it build on its past successes and failures. It's how we can help it finally stop reinventing the wheel with every new challenge. And now a new research paper is introducing a framework to do exactly that. It's called Mem-P. Think of it as memory with procedural power. It's designed to be a flexible system that treats memory not as some add-on, but as a core, learnable, and constantly updating part of the agent itself.
Okay, so how does this thing actually work under the hood? Well, Mem-Pro runs on this really simple but incredibly powerful cycle. Build, retrieve, and update. So first up, it builds the memory. After a task is done, the framework helps the agent boil down that whole experience into a reusable procedure, kind of like a recipe. Then it retrieves it. When a similar task pops up, the agent just searches its memory for the best recipe to use. And finally, and this is the real secret sauce, it updates the memory. It refines and fixes its procedures based on the results, making sure it learns from mistakes and doesn't make them twice. Let's dig into that build phase for a second, because it's pretty clever. The system can store memory in two ways. It can save the trajectory. Think of that as the raw camera footage, with every mistake and wrong turn included. Or it can create a script, which is like the final polished movie, just as successful steps. And what the researchers found is that using both together, the detailed example and the clean summary, gives the absolute best results. All right, the theory is great, but the big question is, does it actually work? Well, to find out, researchers threw some seriously complex tasks at Mem-P, like planning a trip with a ton of tricky rules or navigating a virtual house to do chores. And the results? Whoa, they are seriously dramatic. Just look at these numbers. On the ALFWorld Household Task Test, a top-tier model like GPT-4o with no memory succeeded about 42% of the time. But bolt-on Mem-P? Its success rate skyrockets to nearly 78%. I mean, that's not just an improvement, that is a total game changer. And it's not just about getting the task right, it's about getting it right faster. With this memory, the agents got way more efficient. In one case study, an agent solved a problem in 9 fewer steps. That's a massive saving in time, energy, compute power, you name it. It's learning to cut out the fluff and get straight to the solution.
But here's where it gets really, really interesting. This knowledge isn't just locked inside the AI that learned it, it can actually be transferred.
So the researchers tried something absolutely brilliant. They took the memory built by the super powerful GPT-4o and just gave it to a weaker model, Quen. And boom, that weaker model instantly got a 5% performance boost. It's literally like an apprentice learning from a master craftsman just by being handed their notebook of secrets. Okay, so let's zoom out for a second. What does all of this actually mean? Because this is way bigger than just helping an AI score better on a test. You know, this quote just nails it. We're talking about a fundamental shift here. Moving away from AI as a static tool that just follows a list of instructions and towards a dynamic partner that genuinely learns its craft over time. And this is how we get there. This is how we get to agents that are truly autonomous, agents that are more resilient, way more efficient, and can handle all the messy, unpredictable stuff the real world throws at them,
all without needing constant human handholding.
So that leaves us with a pretty mind-bending thought to wrap things up. As these agents get better and better at learning on their own, they won't just be tools we use. They could become true collaborators with their own unique skills and experiences. The real question then becomes, if they can learn from their own experiences, what are we going to end up learning from them?